Welcome to Unit 1 Programming 101. We're going to briefly go over some information on programming, just give you a general background as to different types of languages and different type of programming software. By the end of this unit, you're going to be able to discuss the following: to compare and contrast game engines and programming languages, know the difference between compiled and interpretive languages, how to identify different variables and create variable lists, the use of condition statements and concepts of looping, the organization and how to properly save files, and raster versus vector graphics. That's just the tip of the iceberg when it comes to programming, but knowing this information will give you a good solid start to move forward. We are going to start off in section 1.1, knowing the different programming genres. Okay, first we're going to talk about game engines. You're going to hear this term quite a bit, especially from students that are really involved in video games. Okay, so a game engine is a software development kit that provides key characteristics that you would find in a game. Some game engines give you physics, animation, they help you with the collisions between objects, the rendering of your graphics, whether they're 2D or 3D. Artificial intelligence, it helps take some of the legwork out of having to actually manipulate the computer to almost seem like it's thinking. It allows you to network your games, especially if you want games to be able to have multiple players in an online forum, whether it's a mobile device or like a first-person shooter on your major console systems. Helps out with sound and scripting. So game engines help take a lot of the legwork out of your learning curve to be able to start making video games. They do a lot of that up front to help make it easier for you. To give you an example, this is the Unity 5.6 game engine. It has a sample product out here you can just check out. If you're interested in Unity, you can go to their website, unity3d.com, and get a free personal edition. It's a great tool to go out and start learning how to program. I use this in my upper level computer science students. However, just starting out, I think starting with Scratch is a good way to go to get some of the fundamental concepts. And there's other game engines out there. You'll hear people argue about it all the time. In the end, it really depends on the developer. It just gives you a brief knowledge base of game engines. However, let's talk about programming languages. Programming languages are the way of communicating with a computer in order to get to do something that you want. Languages the computer uses are built around logic, and that logic is the way we think about our world and how we make decisions. Believe it or not, you use logic all the time, and if you think about it, someone has had to program your mind in order for you to think certain ways. Okay, for example, someone has programmed your mind to allow you to think, to know that something might be danger even though you've never experienced that. Okay, and that's what we're trying to do with a computer, to get it to think with us giving it information. Now, programmers, they make everything the computer needs to do something. It could be software that monitors water treatments, your internet search engine, cell phones, computers in your cars, missiles, robots. I mean, basically anything with electricity these days has some sort of computer attached to it. And a programming language usually has a steeper learning curve than a game engine. Now, some of you might argue with that if you have experience with game engines. Some game engines are very complicated. It almost seems like just doing a regular programming language is easier than trying to figure out a game engine. But long story short, on average, learning a programming language is a little bit more difficult than learning a game engine. Now, programming languages come in different types. A compiled programming language takes all the code that you create and converts it into something called native code for its final product. And native code is all the ones and zeros that you've probably seen associated with, like technology, or if someone's like being funny in a cartoon or something, the robot's talking in all ones and zeros, or maybe you've seen the old movie The Matrix where everything there's a bunch of ones and zeros that make shapes. Okay, that's the native code. Compiled languages make software that's very fast, so the programming language is translated permanently to a native code, which allows the computer to run it very quickly. There's three basic steps to creating a compiled programming language. This is called the edit, compile, run cycle. First, you edit, which is writing and finding problems with your code. Second, you compile it, you turn your code into native code, and third, you run to test your program and just to make sure it runs how you want. Okay, and down in the last bullet point, I've got some different languages that are pretty popular compiled languages. Personally, I'm a C# and Java person. That's just because that's my background. Some people would say C# and Java are almost the same, and I would actually agree with them. So there's a lot of languages out there, and if you find one that you like, I definitely encourage you to pursue that. The other type of programming language we have is called interpretive language. And in programming, interpretive languages, they read the code every time you run it, and then it converts it to machine code as it runs the program. It does not compile the code to ones and zeros beforehand, so it's converting it to machine code on kind of like a just-in-time perspective where it's just doing it as you go along. A major benefit of interpreted languages that they're easier and faster to code than compiled languages. They typically have less rules. One problem is the software could be slower than compared to compiled languages. A positive aspect of interpreted languages is that you can adjust the code while it's running, and you'll see that inside Scratch. Scratch is an interpretive language, and it's a great way to learn how to program because it cuts down that development cycle that we looked at earlier, because you're able to make adjustments while the program is running. There's a lot less rules that holds us back and stops us from shutting down the whole system if we have an error. Examples of popular interpretive languages out there in industry, you'd see JavaScript, Python, and Perl. These next couple slides are my personal spin on programming, and I bring this up because if you're taking my class, you're learning how to program in Scratch. And Scratch is what I call an education programming language. And there's a lot of these out there. And what this means is that education quality codes can be either interpretive or compiled. There's some examples right there, such as Scratch, Alice, Greenfoot, Kodoo, Lego Mindstorms. And in educational quality code, it's intended to make it easy to learn how to program. Okay, they're made for education, they're made to teach with. Now, the software made with education software development kits, it can be excellent. It can be, I've seen some very good programs made by some very good students, but these programs, since they're made with an education-based product, you can't really get a lot of the features you need for a commercial deployment of the software, especially with a lot of the quality assurances or making sure the data has a high level of integrity. Okay, and those are concepts that are way beyond what we want to deal with right now when we're just learning how to code in Scratch. And also another thing is most programs created with education software, it's open source. So that means anybody can access it and you can't legally go out and sell it. So anything we make in Scratch, you won't be able to go out and start selling it at any of your major video game retailers. The source code, that refers to the code that was created to make a computer program, and most typically the completed code for the software. So you will get access to a lot of source code from me for Scratch programs, and you'll also be able to access other, as they call them, scratchers out there, all their source code for their programs, which is a great way to learn. Now, on the flip side, compared to education programming tools, we have production programming tools. And these production programming tools, they are high quality, they can be compiled or interpretive, and a production quality code is designed for the programmer to create an application that is intended to complete a certain task for the end user. Okay, and these software contain advanced data handling capabilities and abstraction. Abstraction is a good word to know. We'll cover that later on. But it's the programming language hiding a lot of details, so you as the developer don't get confused by too many details being thrown at you. Okay, and that'll make more sense as we move along. And again, down at the bottom are a list of some different programming languages that are good for production quality code. When you do get to the point that you want to move forward and start learning a production quality code here, there's some steps you need to take. One, research what type of language that's going to help make the software that you want to create. Some of those different programming languages can all make the software that you want to make, so it's going to come down to you having to pick a language that you're interested in. Okay, so pick something you're interested in. Third thing, forget the critics. Don't pay attention to other people. You're going to hear everyone's opinion on what you should be doing. Don't worry about them. Follow your instincts, follow your heart, and then go to number 4, practice, practice, practice. And then 5, master that language by investing your time and you want to not do something called chasing the rainbow. And that's a term associated with the personality type where it's always looking for the latest and greatest, which is good. There's nothing wrong with that. But there's a point in time where you've got to go in and learn how to master that particular type of entity. If you spend all your time just researching what's going to be the best, you'll actually never take that time and invest it into learning how to program with that particular language. All right, that wraps us up for section 1.1, and we'll see you in the next video.